It's a good time to enjoy the beauty of advanced chemistry. How are you, everybody who is watching this fantastic video? I'm very happy to have you today. I would like to take this opportunity to welcome everybody who is watching this fantastic video. My name is Olenjolai Moko Tayai Losingo. Simply call me Olenjolai. I'm a chemist and I'm responsible to teach you the beauty of advanced chemistry. Not only the advanced chemistry, the beauty. Okay, the goodness of advanced chemistry. So stay tuned, and I would like to welcome national and international viewer into this more interesting point of view. So I'd like to take these few minutes to welcome you into one of our online school. That is called the TANZANIA Online Advanced Secondary School in square bracket Olenjolai. Because I'm also a mathematician, I would like to take this opportunity to welcome you into one of our official YouTube channel that is called TANZANIA Online A-Level Circuit School in square bracket Olenjolai. And then I know that you are asking yourself so many questions if this is your first time to meet me, because I thank God by His own grace. I think differently, I act differently, I teach differently, and I grasp every concept in a different way of approach, because I have actually a kind of destiny whenever that I teach any kind of the session. So possibly you're asking yourself so many questions, but the common one which I can answer quickly to you: what is the visions of TANZANIA Online Advanced Secondary School? That's the very good questions and very interesting question, because you're actually asking a question which has been answered or which has been discussed in the Word of God, written in the Bible. For instance, Proverbs 2019, chapter 19, verse 18, is stated that where there is no vision, people perish. If in TANZANIA Online Advanced Secondary School, in square bracket OLENJOLAIM, we don't have vision, then we are going to perish. So, and myself, I'm not ready to perish, and that's why that I'm declaring the vision of Toaso. So what are the visions we have? What the picture? Because visions is God's picture, or is God's purpose revealed in the mind of the person in form of picture. So we have a picture in our mind. This is our vision. We have an assignment to teach and train some group of advanced secondary students on how they can extract knowledge, understanding, and wisdom from the classroom instructions in advanced chemistry, basic applied mathematics, advanced physics, and even advanced mathematics. And combine this knowledge, understanding, and wisdom with the knowledge, understanding, and wisdom that we are going to teach them to how they can extract it from the Word of God in order to solve real life problems. So if you're asking me a question, Olenjolai, what is the main objective of TANZANIA Online Advanced Secondary School in square bracket Olenjolai? That's a good question. And the answer is the main objective of TOASO is to train, incubating, mentor, lead, encouraging, and training advanced secondary students on solving real life problems. So helping you to get prepared, or in order to become victorious, or to have a good, or to have excellent continuous assessment, it's one of our specific objectives. Helping you to pass your certificate secondary education examination, for instance in chemistry, is one of our specific objectives. Our main objective is to see our continuing or our advanced secondary students who are still studying, and even those who are graduating, they really try to convey the information, which we call the knowledge, and understand that information, and think outside of the class on how they can apply on solving real life problems, because that is objective of education. The objective of education is not you to have a certificate. It's not you just to become popular in the family because you are most educated, or you are more educated than others. That's not the case, right? So that is our vision, and that is our main objective. So we are declaring, and we want to build this concept in our students, so they have to know why are we working hard and why are we doing what we are doing, because we are going somewhere where actually right now it's invisible. Okay, again, you can ask me a question. I know that you can ask yourself, Olenjolai, I used to trust you, but today you are lying to us. How is it possible for you to combine the two knowledge, It means the knowledge from the classroom instructions in science and mathematics, and the knowledge from the Word of God, or understanding of science and mathematics just in school, and then the understanding of what of the Word of God. How is it possible? Is this possible? Yes, the answer is yes. Myself, I'm a product of what I'm telling you. So before I took a step to teach others on how they can combine these two knowledge, these two understanding, and these two wisdom, and use it to solve real life problems, by God's grace has given me so many practice on how I can practice the idea before I declare it publicly and build it in the mind of other people. So myself, I'm a product of it, and then you can ask me another question. Tell us an example of real life problems you have ever solved it by using the technique you're telling us, or telling us the one real life problems that you are solving right now. The good questions I gave. The program you're watching right now, it's a result of what I'm telling you. The idea is not mine, the idea is from God. But under that circumstance, I had extracted knowledge from the Word of God and combined with the information that I had in science and mathematics, and then I said, yeah, I can make it. So, however, that it may take several months or several years to achieve what I'm telling you, but that's not the case. It's a matter of the time. We are going to give you right information, so just don't worry about the time. If it will take you 2 years or 3 years, the issue is you have to know that we are going to teach you to think it differently on how you can solve real life problems. So I think that I've tried to answer your common questions and then say, okay, so now we understand you, sir. Can you take us inside the class of the today? Yeah, I can do that. But before I do that, let me take you into the next step of how you can register yourself. Whenever you go any physical schools, the first thing that you do on the first day or first week is registration. Then, how can you register yourself to ASO? To ASO, this is the abbreviations of what? So to ASO, this is the abbreviation of the word. So to ASO, registrations to ASO. These are the abbreviations of Tanzania Online Advanced Secondary School in square bracket Olenjolai. The first step, if you don't have an email, you have to create or open a new email at the first step. The second step, if you have an email or you open today, how can you create an email? Just go to the Google and then just write in the search part of the Google, of the search engine of Google, how can I create a new email? And have possibility of either of the two emails. It might be, for example, it might be Yahoo email, okay, Yahoo email, or it might be what? A Gmail, Yahoo email or a Gmail. The second step, you have to sign in YouTube, okay, by using your email, the one that you've created, or the one that you used to have. When you be signing, it means that the YouTube community will ask you your username and your password, so you should have them in your hand when you are signing in YouTube. Because if you don't have an email, you cannot be registered into ASO. If you cannot have if you don't sign in YouTube by using your email, you cannot be registered into ASO. So the prerequisite for you to be registered is to create a new email. If you have the one of your old email, it's fine. You can use it as long as it's an active email. The third step, after you have signed in YouTube, it means right now you're in YouTube. In YouTube, you search to ASO. Never write to ASO, just write Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM. Copy and paste this phrase, Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM. The next step, which is the fourth step, click the playlist. Why should you? Because first of all, if you search this name at Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM, then you will see the icon like this one. Then here you see to ASO in the long terms, right? So you see to ASO, Tanzania Online Advanced Secondary School in square bracket OLENJOLAI. So click this button, and inside of this software button, you'll see what is our national flag. This is the national flag for Tanzania. I'm a Tanzanian, and I'm doing this program to benefit advanced secondary schools of Tanzania and international students. Okay. So the next, and then they say the first step, you have to create a place. Once you are inside our school, you'll see home. Okay, see a place which will be written home, but in uppercase. Okay, home, and then see videos. Okay, and then see playlisting. Okay, playlisting. and then we have channel, we have community, then we have about. So click this playlist. Why should you click the playlist? For example, in case of electrochemistry, we have a playlist which is called the electrochemistry. Say electrochemistry. This is one of the playlists. We have another playlist of what acids, which is called acids, bases, and salts. Okay. Again, we have another playlist which is called the advanced chemistry. What is advanced chemistry from 6. So, what the mixture playlist means that in one playlist we use to collect all the videos of the particular topic, all the videos of the particular subject, all the videos of the particular main topic, all the videos of the particular class. So our departments, for example, here we have departments of advanced chemistry. So you have a playlist where we'll be collecting all the videos which will be training advanced chemistry from the first chapter of the Form 5 to the last chapter of the Form 6. And then have another playlist at the minutes of which is called Advanced Chemistry Form 6. But we are still doing research. We might ignore this one. We might just end with playlist of the particular subject and not playlist of the department. Right? But we are still doing the research. So we have a playlist. The topic there, the main topic is electrochemistry, and then the topic is acid, bases, and dirty. And so we have a playlist of acid, bases, and dirty. And so if you go into this playlist, you will find possibly 22, for example, videos of acids, bases, and salty. You'll never find maybe any video which will be teaching you about gaseous state. You'll find the lectures of all the videos about gaseous state in the playlist of state of matter. Okay? So we like to give you these instructions because if you don't follow them, you may be spending much time on looking the consecutive session. So the 5th step, we ask you that to click this button. So now you are already indulging in the position of being registered. You can start this step number 5, then come next step number 6. So with this one, I'm saying there's a button. If you look at your right hand side, you see a software button at the bottom, which is called subscribe. So if you click this button to subscribe, then you find that the word will change into subscribe. And once they change, then you have an icon of the bell. Okay? So if you click this icon of the bell, you choose the option of all. Okay? So subscribing, so choose the options of all. Number 6. Okay, number 6. The 6th step, you say that after you've done that, you can also click on the icon which is written live, like the video, or icon of dislike, or you can click the icons of share. So you can share the link of this video to your friends, to friends via Facebook, via email, when you created it, and share with your friends via Twitter, via Telegram, via Instagram, via WhatsApp, etc., etc. So those are the steps that you have to follow for you to be an active. The good thing, so once you click these buttons and the word change into subscribe, and then you click the icon of the bell and choose options of all, you have been registered permanently in Tanzania Online Advanced Secondary School in square bracket Olenjolai. There's no maybe frequently or often registration. You have to register yourself once. We have so many departments in our online school. One of the departments is called Departments of Advanced Chemistry. The subject today is called Advanced Chemistry, and this is for the pre-Form 6 or Form 6 or class 12 in some of the countries. For example, in India, Form 6 is called the class 12. Okay, the main topic is called electrochemistry, And then this electrochemistry has also 3 topics. The first one is called the electrochemistry itself. The second one is called the acid, bases, and salt. And the third one is called the solubility product, and ionic product. So, ladies and gentlemen, let me do the quick review of what. And this is session what? It's session 2, introductions of ionic equilibrium of acids and bases. So just to quickly remind you, just to do the quick review. Okay, quick review of what? Of session. Quick review of session 1. So in session 1, basically, we have shared with you the big picture of what? Big picture of electrochemistry. Where do you get electrochemistry? So electrochemistry is one of the branch of chemistry. Okay? And then we talked over here with you about topics, main topics, okay? Main topics or chapters of 40 of electrochemistry. No, main topics of chemistry, of advanced chemistry. So this means main topics of advanced chemistry from Form 5 to Form 6 according to the syllabus. Okay? And then she shared to you about topics of 40 of advanced chemistry. Because the main topic, you find that it contains 2 to 3 topics of chemistry. So for advanced chemistry. Then afterward, we taught you or we presented to you about when it comes to electrochemistry, then we learned about the main topics of electrochemistry. As I say, main topics of 40 of electrochemistry. So main topics of electrochemistry. We said 3 main topics of 40 for electrochemistry. Then afterward, we presented to you about subtopics. That's what we call subtopics. It used to be called subtopics, but for we call the topics of 40 of electrochemistry. Then we presented to you specific objectives of each topic or subtopic in other ways. So that's what we've done in the previous study of session 1. So today, let us continue with our process of learning. So we say that you have acids, bases, and salt. So today we'd like to begin with this one about contents. Let me present to you about contents of what? Contents or subtopics of 40 of acids, bases, and the salts. Okay? First subtopic which we have to cover, we call it in chemistry the general introduction. General intro of what? Of acid, base, and salt. Then the second concept that you have to cover, types of electrolytes, which I'll teach you today. Types of electrolyte. Types of electrolytes. How many types of electrolytes do you have? Okay, types of electrolytes, which means we teach you electrolytes and the types of electrolytes. Then the next step that we are going to teach you is dissociation. We touch a little bit on dissociation. Dissociation of what? Dissociation of weak electrolyte. Dissociation of weak electrolyte. Dissociation of weak electrolyte. Dissociations of weak electrolyte. Weak electrolytes. Then the first step or the first concept that we're going to teach you, we're going to teach you about the Oster dilution law. Oster dilution. So Oster dilution law. This is the law which is going to govern us when we're doing the problem solving. Then the next subtopic is called the derivations of the formula of finding degree of what? Degree of dissociation. Okay. Derivation of formula of dissociation constant. Okay, dissociation constant. Then dissociation constant will be deriving degree of dissociation. Alpha is degree of dissociation. Ka is the dissociation constant of acid, and Kb is the dissociation constant of 40 of base. Then the 60th step, we are going to teach you how you can find out Ka, Kb. So how you can find concentration of hydrogen ions and concentrations of hydroxide ion for bases. Then the 7th step, or the 7th concept that we are going to teach you, we are going to teach you about concepts we call the pKa and the pKb. Then the 8th step that we are going to teach you in this concept, we are going to teach you about ionic product of water and pH. Ionic product of water and the pH. So ionic product of water and what? And pH. Then okay. So before teaching ionic products of water and pH, I'm going to teach you about pH and pOH. How can you compute? We know that during your Form 2 education, we have just told you that the pH of base, the pH range of base, and the pH range of what? Please copy these steps for you to register and be a permanent student. Why should you subscribe? That's a very important question. The aim for you to subscribe is in order to get official notification once we add a new video, because we are adding new video every day, at least one video in a day. So the YouTube community will give you notification. Pause the video, copy those steps. Thank you. So give you the official notification once we add a new video. Okay, so pH and pOH. So the 10th step, or the 10th concept that we are going to teach you, we are going to teach you about derivation of what? Of pKw. Derivations of Kw. Yes, of Kw, and then use the dissociation constant of water, and then pKw. So that's what you have to teach you on how you can derive with this stuff. Then the 11th concept, we are going to teach you about Arrhenius concept. Arrhenius concept. Arrhenius concept of acids. Then we teach about Arrhenius concept of bases. Arrhenius concept of acids and Arrhenius concept of bases. Then we teach about the concept of what? Concept of Lowry, concept of Lowry-Bronsted, concept of Lowry-Bronsted of acid and base. Okay? Concept of Lowry-Bronsted of acid and base. The 14th concept you are going to teach about buffer solution. Say buffer solution. So you teach about the buffer solution. Then the 15th concept you are going to teach about the pH equation of buffer solution. pH equation of buffer solution, and also pOH equation buffer solution. Okay? Then the 16th step, after teaching the pH equation of buffer solution, we'll be teaching about problem solving. Problem solving. Okay? Problem solving. Okay? Then 17, we'll teach about salty hydrolysis. So these are the concepts or subtopics that we are going to cover in this topic. Actually, if you see that listing, you know that you have to work hard as chemists. But don't worry, I will be helping you, and I'll be with you, taking you from one concept to another concept, and you'll find that you master this stuff after a short time. All right? In case you have any question about about this lecture or this session, please don't hesitate to ask in the comment section below there. Ask your question that I need to understand. Use the comment section to establish the online group discussion. Use the comment sections to give me the feedback, whether you understand what I'm teaching you or not. So let us begin with the first concept at the general introductions of acid, base, and salt. And before we take that overview, we have to focus on this term. First, the terminology. The terminology, which are equal to the main topic. The main topic, which is called what? Electrochemistry. Say electrochemistry. The fundamental question that we have at chemistry, before we go inside chemistry, what is electrochemistry? Pause and ask yourself this question. Try to answer on a piece of paper, or ask your neighbor if you're watching at the group. Okay, what is electrochemistry? What is electrochemistry? What is electrochemistry? What does it mean? What is electrochemistry? Ask yourself, and then ask your neighbor, my dear student, my dear friend, what is electrochemistry? There are so many definitions, but I found two. And this is what I want to share with you. In chemistry, the word electrochemistry is a branch of chemistry. It's the branch of chemistry. It's a branch of chemistry that deals with the relations between electrical and chemical phenomena. That deals with relation between electrical and the chemical phenomena. Chemical phenomena. So in chemistry, electrochemistry is the branch of chemistry that deals with the relations between what? Electrical and the chemical phenomena. By means of electrochemistry. Relations between electrical and the chemical phenomena. This is according to the Oxford Dictionary. This is according to Oxford Dictionary. What does this mean? For example, we have something we call it, in real life, a battery. But technically, or in chemistry and even in physics, we call it a dry cell. So you know a car battery, for example, car battery, or even maybe a radio battery. For example, in Tanzania, we have national battery, we have BASES battery, and we have Panasonic. Previously, we used to have Panasonic batteries. So those batteries, actually, how do they produce power? And actually, we say that because most of those batteries, if you, for example, if you exclude the car battery, for example, all the dry cells are unrechargeable source of energy, cannot recharge them, right? So how, for example, a battery of your remote, of the remote control of your TV gives power into that, or into the motherboard of that remote? That's the question. So the principle behind is this: inside of these batteries or dry cells, there are a chemical process or chemical reaction which, whenever it takes place, is conveyed the chemical energy stored inside the battery into the electrical energy. So remember the principle of energy conservation. Energy cannot be created nor destroyed. So from the definitions of the electrochemistry, you cannot start. How can you take the information we are teaching you in electrochemistry in order to solve real-life problems? Because electrochemistry gives us one of the products, which is dry cells. We are using always just to power our remote control for the TV, remote control for the AC, air conditioning, and then remote control for possibly that you have flat screens or whatever, or remote control for all other electronics and the electrical consumer devices. So all of these are result of electrochemistry, conversions of chemical energy into electrical energy. And the principle or the concept that you are going to study, especially in electrochemistry, is called that concept, the one that I'm discussing, electrode potential. So because we say that in electrolysis we have electrode, okay, and this electrode we have anode and cathode. So that the principle. Also we have something we call the electrolyte. Okay, so this is one of the definition. So other sources also define what the electrochemistry is: a study of productions of electricity from the energy released. So electrochemistry is a study So it's a study of what? So it's a study of production of electricity. It's a study of production of electricity. So it's a study of productions of electricity from energy released during spontaneous energy released from spontaneous chemical reactions. From spontaneous chemical reactions. From spontaneous chemical reactions. So we say that it's a study of production of what? Of electricity from energy released from the spontaneous reaction and what? Okay, from spontaneous reaction, not from, so during, released during spontaneous reaction, that's chemical reaction, during spontaneous reaction, and the use of electrical energy to bring about non-spontaneous chemical transformation, and the use of electrical energy to bring use of electrical energy to bring about non-spontaneous chemical reaction, to bring about non-spontaneous reaction. Non-spontaneous reaction. Okay, to bring about non-spontaneous reaction, non-spontaneous chemical transformation. Spontaneous chemical transformation. Okay, so let me explain this definition. So the second definition of electrochemistry says that electrochemistry is a study of productions of electricity. From what? From energy released. So the energy, this energy will be released during spontaneous reaction of what? Spontaneous reactions within the electrolyte, okay? And the use of electricity. Also, it means that we can use electrical energy to bring about non-spontaneous chemical transformation. So, we have spontaneous chemical transformation and non-spontaneous chemical transformation. What the difference between the two? So think about that. Okay? So the next concept is about types of electrolytes. So I'm going to teach you about types of electrolytes, but before I teach you types of electrolytes, let us discuss the meaning of electrolyte, because it's not the first time we taught you the concept of electrolytes in chemistry when we've been teaching about the concepts of what electrolysis in Faraday's during your O-level education. Okay? So we have again the terminology which is called the electrolyte. Ladies and gentlemen, say electrolyte. Say electrolyte. Okay? Electrolyte. So the question here is, what is electrolyte? What is electrolyte? What is electrolyte? That's the question. What is electrolyte? So in chemistry, we said that electrolyte is a substance that produces an electrically conducting solution. Is the substance, electrolyte is a substance that produces what? That produces an electrically. So let me write this definition and explain it to you. Is a substance, or is a substance that produces an electrically conducting solution electrically conducting what? Solution when it is dissolved in a polar solvent. In a polar solvent. In a polar solvent, such as water. Such as water. So that's the meaning of what? Of electrolyte. So electrolyte is a substance that produces an electrically conducting solution when it is dissolved in a polar solvent. We have polar solvent and non-polar solvent in chemistry. Electrolyte is a substance that produces an electrically conducting solution. So when we take that electrolyte and dissolve in a polar solvent, so it means that electrolyte has a characteristics of producing electrical conducting solution. If you take that electrolyte, for example, sulfuric acid, and then you dissolve it in polar solvent like water, right? That's a very important point. This is one of the definition. Before I give you an example, let me give you another way, alternative way of defining the word electrolyte, or electrolyte. Electrolyte is a substance which is in either molten or aqueous state. Molten or aqueous state. Molten or aqueous state. Molten or aqueous state which conduct electricity. Molten or aqueous state which conducting what? Electricity. Which conducting electricity. So simply electrolyte is a substance which is in either molten or aqueous state, which conducting electricity. Which conducting what? Electricity. So electrolyte is a substance which is in either molten or aqueous state and conducting. So it's a substance which is in either molten or aqueous state and conducting, which conducting what? Electricity. So I'm trying to check the grammar here, which is either. So this slash is either in what? So either molten or aqueous state. And aqueous state that conducting what? Electricity. So is a substance which is in either molten or aqueous state to conduct what? To conduct electricity. So to conducting electricity. What are the examples of electrolytes? That's a very good question. So examples of electrolytes, we have this because you are advanced secondary students. We have sulfuric acid, it's an electrolyte. We have hydrochloric acid, it's an electrolyte. We have sodium hydroxide, it's an electrolyte. We have potassium hydroxide, it's an electrolyte. And then you have what? We have benzoic acid. Okay, so benzoic, we have benzoic acid, benzoic acid. And then we have ethanoic acid, so CH3COOH, ethanoic acid. Okay, and also those are the weak acids, or wiki. Then we have ammonium hydroxide. This is the weak base, okay, because we have strong electrolytes and weak electrolytes. So we have ammonium hydroxide, Okay, ammonium hydroxide solution. So we have, again, we have what? Yes, even, I'm not sure about calcium. Yeah, calcium hydroxide. So calcium hydroxide, etc., etc., etc. So these are the examples of electrolytes that we have in chemistry. You have sulfuric acid, you have hydrochloric acid, you have sodium hydroxide, you have potassium hydroxide, you have benzoic acid, you have ethanoic acid, you have propanoic acid, you have sodium, you have ammonium hydroxide, you have calcium hydroxide, etc., 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 etc. So, in case you have any question about definitions of electrolytes or the meanings of electrolytes, then please don't hesitate to ask in the comment section. And I believe that you are enjoying the beauty of electrochemistry. You enjoy the beauty of the topic called acid, base, and salt. So, ladies and gentlemen, when you are copying the definition and think about that definition, I would like to teach you about types of electrolytes. How many types do we have of electrolytes in chemistry? Okay, so it depends. You are learning this concept at what level. If you are in the specialized level, then you can learn it and you can learn different types of electrolytes. But in this level, we have been recommended by the syllabus of advanced chemistry for advanced secondary education from 5 to Form 6 of Tanzania, right? That you have to teach our students only 2 types of electrolytes. So you say that in chemistry, there are 2 basic types of electrolytes. These are, the first one, we call it strong electrolyte, which you are familiar with. And the second one is weak electrolyte. And I want to tell you that the entire study of ionic equilibrium of acid and base as one of the subtopics, because we say we have 4 subtopics in this topic of acid, base, and salt. One is called the acid and base, and then the second subtopic is called the ionic equilibrium of acids and base, and then the next one is called the, if I'm not mistaken, it's called the buffer solution, and then the last one is called the salt hydrolysis. So we have 4 subtopics, remember that. And we have listed the contents for all the 4 subtopics. We've listed all. So the previous list was the list of acids, bases, and salt. So it means in the ionic equilibriums of acid and base, we'll be studying about the associations of weak electrolytes. About our subject or case study, our focus will be focusing on weak electrolyte. And we'll tell you the reasons why. Because many chemicals, many pharmaceutical chemicals, many industrial chemicals are made by by weak electrolytes. Why? Because strong electrolytes is kind of poisonous and it's dangerous for the human life. So it needs too much of precautions on handling. So before we discuss or just I teach you about those two types of electrolytes, I would like just to give you one of the important announcement that in Tanzania Online Advanced Secondary School, Olenjolai, we don't have only a school where we are training students, but also we think by God's grace, we have something we call it TOAL. TOAL, it's abbreviations of this phrase, Tanzania Online Advanced Library. In this advanced library, we don't need to teach our students only, but we like also to equip them with relevant material and the actual essential material for them to go further as well as they can. The first items that you'll get in our library, it's a copy, original book, or a copy of the chemistry syllabus for advanced secondary education from 5 to Form 6. So you can order this book. It is cheap, actual. So you have to order it in and enjoy the beauty of advanced chemistry. It's very important. I recommend to every student of TOASO to have this book in your hand so that you can know the boundaries, you can know where the concept we have taught you or we are teaching you it has been written in the syllabus, because even composing exams, this syllabus will be used. But that's not only the case. You'll know the objective of studying advanced chemistry. You'll know at least that what you should be expecting to understand at each of every subtopics. So there are so many advantages of students to have the syllabus in every day, in a daily study. Okay. Secondly, we have also some books that we call them textbook, text reference books. So one of them is the book, we call it in second weapon, Conceptual Chemistry. This is the book which has been written by Dr. S.K. Jain for class 11. So you have Conceptual Chemistry 1 and Conceptual Chemistry 2. It's a wonderful book. It's a huge book. You might be afraid to have it in your hands because you can predict that you cannot cover it. You cannot study every page of it. And it is true, this is the book written by using the syllabus of India, but is useful in the syllabus of Tanzania because we like to teach our students equally as how other international students are used to learn. So you can offer this book. You don't need to read every page of this book. That's why I told you should have a syllabus. So it means you check the syllabus, the concept which has been recommended for you to learn, and then you go to this book and you search for it. Once you find it, you study. That's all. Anything else which is not mentioned by the syllabus and you didn't see in the past papers, you have to leave it. Then we like also to prepare our students for the exam, right? For the classroom exams. So either mock exam or annual exam or pre-mock exams or pre-NECT exams or NECT exams itself. So we have this questions and answers book, Chemistry 1, so Advanced Chemistry 1 Review, what's called Advanced Certificate Secondary Education Examination Paper 1. It comprises questions from 2001 to 2016. So it has questions and answers, but we can just go through sometimes the solutions, there are the mistake, typing errors, there are kinds of the mistakes, so you have to be careful. The fourth sample that we have, representing Tanzania Online Advanced Library, is Advanced Chemistry 2 Review, Problems and Solutions of 2003-2018, right? So that's the case. So you can order all of this book and you can order this entire package. You can order the entire package of the book, but that's not enough. You'll need to use scientific calculator. So you're also having original scientific calculator of Casio function 981, number 1 and number 2, but we recommend number 1 for all the scientists, all the chemists, physicists, and mathematicians, because actually they will help you to do great things in a process of learning. So it means you can order also this scientific calculator and you can send, it means that we can send in all of these packages to your place with a very reasonable cost, because we are servicing our students, we are saving the country, and we are offering our activities to benefit the humanity. So you can order the package, all of this package, including even other books of chemistry, and have the departments of chemistry in your house or in your bag. So you can order them, and there's a great discount if you order the package like this one. So don't wait, go to the descriptions below, and then you'll see more descriptions about TOAL, which is Tanzania Online Advanced Library. Thank you for listening. So let us come back to our session. We say we have two types of electrolytes in chemistry: strong electrolytes and weak electrolytes. So now let us focus on the first type of electrolyte. Strong electrolyte. Say with me, strong electrolyte. Strong electrolyte. So the question is this: what is strong electrolyte? What is strong electrolyte? What is strong electrolyte? So it says strong electrolyte is a chemical substance which dissociate completely in aqueous solution dissociate completely in aqueous solution form free ions. That's the meaning of what strong electrolyte. Strong electrolyte is a substance or is a chemical substance which dissociate completely in aqueous solution to form free ions. So that's the meaning of what strong electrolyte. Let me give you examples of strong electrolyte. Examples of strong electrolytes, we have hydrochloric acid. So hydrochloric acid, when to dissociate in aqueous solution, tends to dissociate to form hydrogen ion, which is free ion, plus chlorine ion. This is in aqueous state, and this is aqueous state. Okay. So that's the first example. Second example of strong electrolyte, because you have to differentiate, is when you have sodium hydroxide and then in aqueous state dissociate in aqueous solution. It's going to form what? So now you know the principle: sodium ion, which is in aqueous, plus chlorine, plus hydroxide ion, plus hydroxide ion, which also in aqueous state. The third example is sulfuric acid. So sulfuric acid in aqueous state, this will form what? Will give us hydrogen ion plus sulfate ion. So here you have 2 atoms of hydrogen, and then you have 1 atom of sulfate and 4 atoms of oxygen. So this also it is still not in aqueous state, and this one is still not in aqueous state. Can you mention the first example of what? The first example of strong electrolyte. Please fill the blank there. Give me the reactants. Because on left hand side we have a reactant. That's we call the reactant. On right hand side we have product. So we need those free ions in order to conduct electricity. Because that's what we say. That we can produce electricity from the chemical reaction. Okay, ladies and gentlemen, let us discuss about the second type of electrolyte. So this is called what? Weak electrolyte. Weak electrolyte. Weak electrolyte. Say weak electrolyte. And I have a question. What is weak electrolyte? The question, what is weak electrolyte? So he said that weak electrolyte in chemistry, weak electrolyte, we say that is a substance This is the substance which dissociates partially to form free ions. Okay, dissociate partially in what? In aqueous solution. Dissociate partially, not completely, in aqueous solution. Form what? Form free ions. Form free ions. By the means of weak electrolyte. So that's the meaning of 40 of weak electrolytes. So it's a substance which dissociate partially in aqueous solution or in solution to form free ions. So because it dissociate partially, we say that only a small fraction of 40 of electrolyte will be, so we say that the only, so few ions will be released. So we have to note this. So strong electrolyte releases many free ions. So while you say this one is a weak electrolyte, weak electrolyte releases few ions. Why? So we say because weak electrolyte releases only few ions. Okay? Why? Why does it release few ions? Because only a small fraction of electrolyte is only a small fraction of electrolyte dissociates to form free ions. So for these reasons, that's why we call them, what we call the weak electrolyte. Only small fraction of 40, small fractions of electrolyte, which is reactant, dissociate to form ions. So large part of reactants remain undissociated. Therefore, the large part of weak electrolyte, remain undissociated. Undissociated. So because the weak electrolyte dissociates partially, then its question will not be direct, but it will be reversible equation. Is it reversible? Let me cross check. Yeah, reversible equation. So we said that dissociation, before we mentioned the examples of weak electrolyte, establishes reversible reaction, establishes reversible reaction. Okay? So establishes what is reversible reaction. So before I go into further concept, let me give you examples of what? Of weak electrolyte. Tell your neighbor that he get prepared to learn examples of weak electrolyte. Examples of weak electrolyte. Examples of weak electrolyte. Examples of weak electrolyte. So the first one is, we call it acetic acid. Say acetic acid. Acetic, or in other names we call it ethanoic acid. Acetic acid or ethanoic acid. Okay? So the molecular formula of acetic acid is this. This is acetic acid before it is dissociated in solution. That's the molecular formula of acetic acid or ethanoic acid. So when it dissociates in solution partially, it will establish a reversible reaction. Like that. So when it dissociates, when acetic acid dissociates, it forms what? Two ions. The first ion is called the ethanoate ion plus what? Plus hydrogen ion. Both of these ions are still in aqueous state. Right? So to write, let me write this equation and divide the space. CH3, I'm just writing that equation. CH3, this is in aqueous state. Hence it undergoes what? Visible reaction. Then here we have what? Ethanoate in aqueous state plus what? Hydrogen ions in aqueous state. So that's the example of acetic or ethanoic acid. The second example of weak base, okay? So for weak base, we have what? Ammonium solution. Ammonium solution. Or ammonia solution. Ammonia solution. Ammonia solution. So ammonia solution, its molecular formula is this. This is ammonium solution. Okay? Ammonium solution. So when it dissociates in aqueous solution, remember that the state, the physical state is aqueous, then it is formed ammonium ion, which is cation in aqueous state, plus what? Plus hydroxide ion, which is also in aqueous state. So because you see reversible reaction, then, because there's something that we call deduction. Deduction is kind of the very powerful principle which combining two things, information and observation. So you are the chemist, whenever you see in chemistry you have reversible reaction, and we taught you the first topic in advanced chemistry from 6 is called the chemical equilibrium. And we taught the chemical equilibrium is all about reversible reaction. And as we taught you something in common which you have been repeating over and over as we've been learning the topic of chemical equilibrium. Can you tell me? Whenever we have a reversible reaction, the reversible reaction used to take, but after a certain time, it reaches to its equilibrium stage, where the reactants will stop to react themselves to form the product, and product stop to react themselves to form reactants. So if the reactions will be at equilibrium, then you have to think about equilibrium constant. And that equilibrium constant is what we call the dissociation constant of acid and dissociation constant of 40 of base. Because this is an acid, but it's weak acid. This is base, but weak base. Right? So you have to understand that. And again, we have another example. This is the example 3 of 40 of weak electrolyte, which is weak acid, which is called benzoic acid. Because those are just alphabetically formed, just a simple molecular formula. So the molecular formula of benzoic acid, first of all, we have benzene, and then we have this carbon oxy hydrogen. So this is what we call the benzoic acid. So when to dissociate in solution, but remember that this one also it is in aqueous state, then it's going to form what? Benzanoate ion. Say benzanoate ion. So benzanoate ion. So choose me. Draw this Kekule structure. Is it Kekule? Ring structure. So this is what? Okay, benzanoate ion, that's what? Hydrogen ion. And this is the upper state, and this is the upper state. So that is the dissociation of benzoic acid. And we are going to discuss all of these examples later on. So again, we say that as weak acid and weak bases or weak electrolytes establish reversible reaction. So we say that these reactions can reach at equilibrium, right? So we say that so we say when dissociation of what? Of weak electrolytes ends in the recombination of free ions to form weak electrolyte, ends. So we say that when dissociation of weak electrolyte ends and the combinations of free ions to form weak electrolytes ends, then the reversible reaction will be at equilibrium. Reversible reaction of weak electrolyte will be at equilibrium. So when the dissociation of weak electrolytes ends and the combination of free ions to form weak electrolytes ends, then the reversible reactions of weak electrolytes will be at equilibrium. What does it mean? For example, we have dissociations of 40 of acetic acid which is common electrodes that we are going to discuss in this topic. And then with this one dissociate, we say that form a somatic ion, N plus hydrogen ions. The physical state of this is upper state, and this one is upper state, and this one is upper state. Okay? So it means before this reversible reaction reaches at equilibrium, then the acetic acid dissociate continuously to form what? Acetate ions and hydrogen ion. And then if, for example, the amount of acetic acid dissociated to form these free ions, if this one is higher than, the amounts of these free ions is higher than the amounts of acetic acid, then these ions recombine together to, by the chemical reactions that we call it, becomes just, it means that they undergo combination reactions to form what? To form reactants. So the meaning of reversible reaction means that this, in this forward arrow, this acts as a reactant, and this form a react as a product. While in this reverse arrow, backward arrow, these two are reactants and this is the product. Wonderful. That's a powerful reversible reaction. So it means that that process goes on, that acetic acid dissociate to form acetate ions and hydrogen ions, and also acetate ions combine with hydrogen ions to form what? Acetic acid. So the process continues until the reversible reactions reaches at equilibrium. So when it reaches at equilibrium, there's no longer dissociation of acetic acid to form acetate ions and hydrogen ions, and the combinations of acetate ions and hydrogen ions to form what? Acetic acid. Do you understand what am I teaching you? Have you understood? Please tell me in the comment section if you've understood. Because these are the critical issues. Are simple stuff if you've been taught it systematically, but actually they are confusing so many students according to my research when they don't understand, when they are not well taught systematically. Because many students need just to run to ostward laws of dilution, but they don't understand and they cannot relate, and they cannot understand why did you cover chemical equilibriums as the first topic before electrochemistry, or before bases and related salts. So if that's the case, you say that this reversible reaction, these reversible reactions of weak electrolytes, obeys law of mass action, or called equilibrium law. So you are going to recall this concept, equilibrium law. So we'll use it in our revision of the formula of finding dissociation constant of acids, the constant of base. We'll be using that concept. So ladies and gentlemen, my father was never said that Olenjolai is enough. So I'm about to end this session because of the instructions which are being given from heaven. I have to make sure that my sessions will not exceed more than 80 minutes, which is actual combinations of the two sessions of 40 minutes plus 40 minutes. So now, before I end this session, let me leave the homework. So join me in the next session, session 3, where I will teach you about dissociations of 40 of this week electrolytes. Okay? So this is homework. Homework and abbreviations is H. This one, this is homework at homework 2. So in this homework 2, we have 2 questions which we'll prepare in the next lecture, in the next session. Okay? Define the term dissociation of 40 of electron. What they mean? Because we just said that dissociation. Then the second question, which is question number 2, dissociation for electrolyte. then state Ostwald's law, okay, of dilution. Then, third question, state law of mass action. So make sure that you do that homework. So this should be example 1. This is example 1. Ladies and gentlemen, this is example 1, which is homework 2 because it's session 2. Define the term dissociations of weak electrolyte. Of electrolytes, we define the meaning of weak electrolytes, strong electrolytes. We didn't touch anything about dissociation. So it's your homework because we have mentioned that term. We mentioned that word several times as we can if you've been listening my session 2. So what the meaning of dissociation? Because remember the heart of Topaso is teaching you the beauty of 40, or just means teaching you how you can understand this stuff. Then we have the second question that state 20 Ostwald's law of dilution, right? And then the second question state law of mass action. Let me check in the symbols. I used to confuse the name of these chemists who calls Ostwald. Okay, so Ostwalds. Yes, Ostwalds. Ostwalds. So this is Ostwalds. 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 Ostwald's law. So this is apostrophe. Ostwald's law of dilution. Ostwald's law of dilution. Ostwald's law of dilution. So just do those 3 questions and then stay enjoying the beauty of advanced chemistry. Stay enjoying the beauty of electrochemistry. Then keep enjoying the beauty of acid, base, and salt, which actually that we have them because you have so many fruits which are source of acid, which contain acid. For example, the lemon, the orange, they contain acids. Okay, when it comes to the bases, actually also we have some of the foods which contains base. We have salts, for example, table salts we use always to add into the vegetables or into the particular food. So what actually we are learning in this topic is we have in your hands. But remember that I told you, your learning should not end in the class in order to pass this certificate secondary education examination, right? Your learning should go to the next step, next level. And the next level is your learning has to make sure that you kick into the concept of how can I apply this information on solving real life problems. This is Olenjolai from Tanzania. I love you so much. And I'd like to invite you in session 3 when I'll teach about dissociation of the weak electrolytes, which actually be focusing dissociation of weak acid and dissociation of weak base. Make sure that you invite your friends. Remember to subscribe into our channel. Remember to like or dislike our videos. Remember to share a link of this video to the hundreds and if it's not the thousands of your classmates who are learning advanced chemistry from 6E and from 5. Again, remember to visit our TOAL, means that Tanzania Online Advanced Library, so you can order your reference books in order for you to master advanced chemistry. Okay? If that's not the case, then we'd like also to ask you or invite you, in case you feel from your heart that you want to offer God the free willing Thanksgiving offering for this program, don't hesitate yourself to send it to us. So look at telephone number 0759745331. Okay? So, and then, or in case you want to do the bank transaction, just go to the descriptions of this video. You'll see the bank name, the bank account, and even the instruction for you just to offer your free Thanksgiving of any amount. Why should you offer? The main reason is your offering will be used effectively on the running cost for this program, because we have a vision of producing more than 500 training and learning videos of advanced physics from 5 from 6E, advanced chemistry from 5 from 6E, advanced mathematics from 5 from 6E, basic mathematics from 5 from 6E, in order to make a radical change in the mind of the students. So remember that that's why you have to offer on an amount, because this is my gifting, and this is my gifting of 40, my gifting that is solving real life problems faced by the Tanzanian advanced secondary students. So you're welcome to offer generous, and may God bless you for your offering. And God may protect you for the thing that you are doing. So thank you very much. I think that you've enjoyed. Let me know in the comment section if you have understood what I have been teaching you from the beginning of the session to this point. Let me put the comments below, please, in order for me to get feedback from you. So may God bless you. This is Olenjolai. I don't know everything about advanced chemistry from 60. I just know a small portion, but I have responsibility to teach others what I know. And that responsibility has been given by my Father who is in heaven, the God of Abraham, God of Isaac, and God of Jacob. So may God bless you and keep you until we meet in the next session. Keep enjoying the beauty of advanced chemistry for your life.